Hello, my name is Cecilio Santos Hernandez, a doctoral student in materials sciences. This is an explanation of the poster that I present at the 31st International Conference on Materials Research. The advisors are Dr. Salvador Ivan Garduno Verdes, Dr. Ventura Rodriguez Lugo, Dr. Maria Isabel Reyes Balderrama, and Dr. Karina Aleman Ayala. The research work is entitled Effect of Thermal Precipitation Treatment at Low Temperature on the Hydrothermal Synthesis of Molybdenum Oxide. Published research highlights that molybdenum oxide as a transition metal has properties that make it applicable in semiconductor materials as a hole transporter layer, since it prevents hole recombination. Sol gel process, magnetic stirring, and hydrothermal process. Thermal process is a widely used process for this purpose. However, it is not clear how thermal precipitation can influence the properties of molybdenum trioxide. In this work we investigate the effect of thermal precipitation at temperatures below 200 degrees Celsius on the properties of molybdenum trioxide. The synthesis is carried out at room temperature with the addition of metallic molybdenum, hydrogen peroxide, and ethanol with vigorous stirring for several minutes. The precipitation process is conducted using three methods: thermal grill, bain-marie, and convection oven. The thermal methods produce powders in blue, yellow, and green colors at temperatures below 200 degrees Celsius. DRX is used to know the structure, FTIR is used to know the elements present, and SEMEDS is used to know the morphology. The structural characterization by XRD determines that our powders are amorphous. Additionally, Fourier transform's infrared characterization reveals the compounds present in the spectrum and locates molybdenum oxide compounds at 400 to 1000 over centimeter wavelengths. The absorption bands of 535, 870, and 988 per centimeter correspond to the asymmetric molybdenum-oxygen-molybdenum, symmetrical molybdenum-oxygen-molybdenum vibration modes, and the stretching vibration of the oxygen-molybdenum double bond, respectively. The sample AM1, AM2, and AM3 present morphology in the form of 3D rectangles, spheres, and in the form of sheets respectively. The sample AM1 characterized by EDS shows that on average the presence of molybdenum is equal to 64% and oxygen of 36% by weight. The sample AM2 characterized by EDS shows that on average the presence of molybdenum is equal to 53% and oxygen of 46% by weight. The sample AM3 characterized by EDS shows that on average the presence of molybdenum is equal to 53% and oxygen of 46% by weight. Sample AM1, AM2, and AM3 present an average particle size of 2.91, 0.27 and 1.97 micrometers respectively. In conclusion, the different colors of molybdenum oxide powders correspond to different oxidation states. Also, an amorphous structure of molybdenum trioxide has previously been reported to inhibit electron-hole pair recombination, which can easily be applied as a hole transporter layer in organic solar cell. Thank you very much for your attention. This was a brief explanation of the research work for the 31st International Conference on Materials Research in Cancun, Mexico, August 2023.